Good morning. Ooh, it's working now. I'm Laura. I'm staff writer at GovCIO Media and Research and your lightning round moderator. I love this panel because the speakers get to choose the topics that they present, and they're giving us a fast-paced look at AI in practice across government and industry. We will hear more about pilots, use cases, lessons learned, and opportunities to accelerate AI adoption. At the end, I'll turn it over to you for Q&A. So first up, we have Brian Frucci, CTO of ClearFracture, to tell us more about preparing for AI adoption.
Welcome, everyone. Good morning, afternoon, perhaps. Appreciate GovCIO for putting this together for us. I'm here. I generally like to start by saying I'm here because data is dumb. All right? I think we all know that. But like oil, it powers. It's essential to powering an engine, right? And data analytics engine. But data by itself just sits there. It doesn't raise its own hand to volunteer to help or tell you about itself or why it matters in your current situation. And this doesn't change just because you have access to an AI chatbot or an agent. So here's the hard truth. AI agents quietly fail, not because they lack reasoning power. They fail because they lack grounding. An agent operating on vague instructions and unorganized situational awareness is just improvising. And improvisation leads to hallucinations, compliance failures, and security risks. So let me put it simply. If your start and end points are fuzzy, agentic speed just gets you lost faster. Every capable actor, doesn't matter if it's a human or artificial actor, needs two non-negotiable anchors before taking confident action. A clear picture of where we are and an unambiguous definition of where we need to go. Turns out that project managers and system modelers have known this for a long time, and their entire disciplines have grown to help organize and optimize human work. Agents aren't that much different, and the same principles apply. I'm not the only one who sees this. As a matter of fact, my alma mater, the University of Southern California, just hired an anthropologist to run their new AI center. So what do you need to do to succeed with bringing the power of AI and its agents to your enterprise? What will take you from here to there? Turns out it's the ability to define those points. The here is where we are, our current situation, environment, and knowledge. This isn't just a chat transcript or a PowerPoint slide or even all the files we have in SharePoint. It must be a living ground truth, the actual systems, data sources, policies, dependencies, quality measures, constraints of your operating environment. Where we need to go, the there, cannot be a vague aspiration like optimize the workflow. It must be a machine-usable specification of done, required outcomes, explicit acceptance criteria, governance rules, and strict guardrails that the agent must never cross. The distance between the here and the there is the actual work. Everything else, the prompts, the LLMs, the workflow orchestrators, that's just how we travel that distance. So there's already robust ways to define here and there, especially for data operations. Think system models, data contracts, semantic layers. The challenge is that building these things is expensive and slow, so it gets avoided. But in an agentic world, not having these representations is a liability. Agents, they amplify whatever context you give them. Trust follows representation. So this is my key insight to get you to success. Use agents to help build your definitions of here and there before you use agents to get you from one to the other. This is why we built Belvedere at ClearFracture. We designed Belvedere to tackle the representation problem head on for data operations. So you don't ask an LLM to magically figure out data ops First, you have an agent continuously discover the living ground truth of your data landscape, mapping sources, schemas, policy constraints, and provenance into a living systems model. That's the here. Then, a user can specify desired outcomes in clear, machine-usable forms. Narrative helps, but also visual activity diagrams, data contracts, that's the there. Then, an agent can reason through that gap and compile a solution. Even better, it can produce that solution as deterministic, traceable code that can't hallucinate, that executes directly on all your existing accredited platforms that you already rely on and can afford, right? And is traceable automation without black boxes. To move AI from isolated experiments to dependable AI operations, we must treat representation as first-class infrastructure. Honestly, getting from here to there was always the entire challenge. In an agentic world, those that succeed will be those that model both ends of the journey and keep those models honest as reality changes. Thank you very much.
Great. Look at you this time. Thank you, Brian. I appreciate the insight into preparing for AI adoption. Next up, we have Stefan Bita from NOAA, who they're already incorporating AI. He is the acting deputy director at the NOAA Center for AI, and he's going to talk about strengthening environmental intelligence through AI.
So at the National Oceanic and Atmospheric Administration, artificial intelligence isn't new. We are building on a 40-year evolution, moving from the 1980s rule-based systems to the 2026 operational reality of how we use it in environmental sciences. When severe weather or wildfires strike, or a need to decide whether evacuations are necessary, every second matters. Our goal isn't to replace forecasters or automate decision-making. It's to give human experts actionable decision support at mission speed. So I'm going to give 3 examples of how we approach this. The first of which is through the use of generative AI for local storm reports. Manual data triage during severe weather events creates a bottleneck during the course of the event. Forecasters have to shift through social media, public calls, and partner reports during live severe weather. What has happened is that we have built a serverless architecture with Amazon Web Services using Bedrock and Textract. A supervisory agent coordinates 5 domain-specific verification agents to cross-reference against radar and station observations. The takeaway from this is that this helps reduce the draft report generation from minutes to seconds, preserves scientific rigor through human-in-the-loop review, and rigorous golden test set benchmarking. The next thing that NOAA is currently working on and has been using is the utilization of artificial intelligence to sift through satellite data in order to detect wildfires. As you can imagine, this year has been a very devastating year when it comes to wildfires across the western United States and even portions of the Central Plains and the Southeast. Satellite data is coming in every 30 seconds to a minute. And it is a cumbersome process for a forecaster or someone to monitor that satellite data continuously in order to be able to identify whether or not they see hotspots for a wildfire on satellite. We have utilized artificial intelligence to be able to do so and to be able to alert forecasters that a hotspot was detected and give that forecaster a chance to evaluate what they see and make sure that it isn't a false report. The result of all of this has caused the ability for us to alert wildland firefighters to wildfires in numerous parts of the country with an average of 17 minutes of lead time before the 911 call. We have done so with 80% accuracy, and we are working to do so with continuing increased accuracy when it comes to the ability to do that. You can imagine what that can do for wildland firefighters if they have the confidence to report to a fire and know that nearly all the time there's a fire that's presently there. The last one I wish to talk about is what we are doing in the space of numerical weather prediction. Global forecasting and data sets require massive computational power and data reconciliation. So we have deployed AI-driven global weather models, known as the AIGFS for short, and neural networks for temperature data, known as the NOAA Global Temp. This allows us to run global weather predictions faster, sometimes up to 97% less computational resources to do so, while maintaining a broad network of observational data that can be come in and assessed in near real time. So the last thing I wish to leave with is that a lot of this information that we are working with, a lot of the data that NOAA works with, we have petabytes worth of data. It will take a long time for us to be able to make it AI ready. However, we have already started that process. We have begun with policy foundation and risk oversight. We have recently signed a NOAA Administrative Order 216-128, in case you wish to look it up, that is accompanied by information for folks within NOAA to be able to leverage artificial intelligence with confidence and do so with policies and safeguards in place. We are also expanding our reach. We have global and interagency reach with artificial intelligence collaborations, doing so through the NOAA Center for AI, through NASA, Department of Energy, ECMWF, our European partners, and the World Meteorological Organization. So with that, those are the case studies I wish to bring forward and the data points to show what the National Oceanic and Atmospheric Administration is doing with artificial intelligence. Thank you.
Thank you, Stephen. I imagine giving firefighters 17 extra minutes to combat wildfires is having a huge impact on saving homes and lives. I can't wait to see how that program matures. Next up, we have Sydney Epner, Product Manager at Uptio. He's going to talk more about understanding and optimizing AI investments.
Hey everyone, I'm Sydney Epner, Product Manager for Workload Optimization at IBM's Apptio Cloudability team. Here's a question for the room. How many of you know exactly what your AI spend bought you last month? Show of hands. No one? Oh, okay. How about not the token count, but like the actual value? If that's a hard question, you're not alone. Everyone's tracking tokens right now. And how many of you, how many we're using and what the budget looks like, but not all tokens are the same, and AI economics is not token economics. We saw a 4.7x increase in model spend in the last 6 months across our customer base. And token cost is only part of that picture. The rest is sitting in the infrastructure, storage, orchestration, and orchestration running underneath it, which most organizations aren't tracking at all. I'm an engineer by training and a lazy one at heart, so I try to recognize new problems as versions of old ones. Early in my career, I was driving all over DC managing customers' on-prem servers. When cloud went mainstream, those servers started disappearing. And the conversation in the room changed from, is the AC working, to who's spending what and why. That shift is what built the discipline we now call FinOps. Who's using the cloud? Why is the bill growing? And what are we actually getting for it? AI is following the same arc, but faster. Cloud spend got out of hand because anyone with a credit card could open an account. With AI, it's even worse. Anyone in your organization with access to a model can generate real cost with no procurement process anywhere in the loop. And that's a big part of why this wave is outrunning cloud. And it's rarely one model or single provider anymore. Across our customers, 88% of organizations spending 7 figures a year on AI are running multiple providers, and our top spenders are averaging almost 3.8 AI services each. Bedrock, OpenAI, Anthropic, internal models, and more, inside the same agency at the same time. So the question has changed. It used to be, how many tokens did I use? Now it's, who's generating this cost? Which mission benefited from it? And was it justified? Those are exactly the sorts of questions FinOps was built to answer for cloud. So we built a similar framework for AI. We call it See It, Assign It, Prove It. See It means getting the visibility into AI spend beyond the model bill. Assigning it means attributing the cost down to the user, the team, or mission that it actually served. And prove it is the part I think that matters most for this room, connecting that spend to the outcomes, whether it's the cost per case processed, the incident resolved, or mission outcome. Not just what you spent, but whether it was worth it. Once you can prove it, the conversation changes. It stops being about minimizing AI spend, and it starts being about optimizing it. For cost, sure, but also for performance, risk, and mission value. And for federal teams, that also includes data sovereignty, security review, and procurement cycle. Cloud gave us FinOps. AI is just the next place to apply it. And the good news is your organizations are already know how to do this because you built this discipline once before. The real question is how to bring the same rigor measuring unit economics for AI that you already bring to cloud. If that's something you're thinking about, come find me or my colleagues here, and we'd love to hear about what that looks like in your environment. Thank you.
Thank you. Next up, we have Colonel Scott Wilson, Chief of Staff at 4th Marine Logistics Group. He is going to talk about enhancing leadership with AI-driven insights.
Hey, good morning, ladies and gentlemen. Quick context, because this is important to the story I'm going to tell you. So I'm an active component officer. I've been in the Marine Corps now for 28 and a half years. Never did any work with the reserves. Don't know anything about AI. I'm not exaggerating. I did not know what an LLM was a year ago. I've learned a lot. I'm the Chief of Staff at 4th Marine Logistics Group. As she mentioned, we have 4 MLGs in the Marine Corps. First is in Camp Pendleton, second is in Camp Lejeune, third is in Okinawa. Those 3 are active component MLGs. 4th MLG is different. 4th MLG is a reserve MLG. I work down in New Orleans. That's where we're headquartered. We have 4th MLG units all over the country. The vast majority of our structure are reservists who put on the uniform once a month for a couple weeks in the summer. And then that's kind of the savings account of logistics combat power for the Marine Corps. That's important context for the story I'm going to tell you. So I got assigned to Louisiana down 4th MLG in 2024. I got down there and I started learning the reserves. I realized that previously they had set aside a few really, really talented officers to be an innovation team. And these officers are reservists who have a deep expertise in artificial intelligence and innovation, modernization, and government contracting. They run businesses very much like all of you. And the very talented and very smart people who are not just your average person in uniform like me who doesn't have this exposure. They had set these officers aside to do this innovation modernization. And after I had been in the job for a few months, they came in for their annual training. They spent 2 weeks down in New Orleans. And they started describing to me what an LLM can do. They started teaching me because I did not know what AI could do. And I'm a little embarrassed to say it, but it's just truth. They started describing this to me, and I have deep expertise in leading Marines at the 05 and 06 level. And I have deep expertise on the surveys that we do in order to assess command climates. And I saw this LLM, and I immediately had a things that make you go, moment, where I go, that would be enormously beneficial in accelerating how we do these command climate surveys. Presently, they take months. We battle low participation rates because they have to have their CAT cards inserted. There's a bunch of obstacles to it. And I said, if we created an easier barrier of entry and we used LLMs to assess the data, this could be exponentially faster and better, and it could lead to better command climates. This is a very easy case study for AI. It took a while for us to develop this prototype. It didn't. It took a while for us to roll this out. The prototype, Sam, one of our innovators, went back and he coded. He's not a coder, but he used AI to code a prototype in 3 hours. And he came back to me and showed it to me and said, that is absolutely astounding and outstanding. And for the last year, we've been battling, and I say that in a positive way, navigating the bureaucracy in order to roll this out to our broader units. We're making progress. We're going to get there. But what we think more broadly is that the Pulse Check survey, as we get this thing rolled out, this AI-enabled survey tool, is going to be our brush-breaking project that is going to enable us to have many more successes like this. That conversation was in May of 2025. We've been working on it ever since. In May of 2026, those 3 officers, the innovation team, came back to New Orleans. They're doing their annual training. We're working on furthering these initiatives. And it occurred to me, remember I said we have 4 MLGs. We have first, second, and third. Those at-the-component MLGs do not have the deep reserve expertise. They don't have these officers that we have in the reserves. I said, why are you guys doing your annual training down here in New Orleans? You should be over at first MLG. You should be at second MLG, and you should be at third. We should be exporting this capability to units who need it. So suddenly we sort of discovered and stumbled on what industry calls the forward deployed engineer model, and that's what we're rolling out. So we're hoping that in the next year, next time I come talk at this forum, we're going to be able to show how we've rolled out the forward deployed engineer concept, how we have enabled AI innovation and modernization at the at-to-component MLGs, and we've been able to accelerate their decision-making and their resource optimization using AI tools that are available to us now. It's incredible what's out there. We're making a lot of progress. And I would say this, you heard from Major Clark earlier. He's institutional level. He's top down from the from the headquarters Marine Corps. We are at a unit who's trying to bubble up. It's the complementary top down and bottom effort that's going to lead us somewhere very productive in the future. And I'm looking forward to the questions. Thanks.
Thank you, Colonel Wilson. We have a microphone here for anyone that is interested in asking questions. Until that happens, I have a few of my own. Stefan, can we start with you?
Sure.
Okay, great. As agencies begin using generative AI and automated detection systems in emergency response, how are you balancing the speed and scale these tools provide with the need for human expertise and verification, especially when decisions impact public safety?
Yeah, that's an excellent question. One of the things that we do is we have a risk management framework for high use cases. And so what you described is a very high consequence AI application where a decision is being made by someone that could be like an alert for a warning of some type of weather event that's occurring. I know you and I had a discussion about a few of those in the back. And what we're using artificial intelligence to do is to help us sift through some of the more menial information and be able to get at a bit more of what we should be focusing on. And we want to do so in a way that ensures that the human is over the loop of the process and it is not an automated process by which we approach. Now, to get at the speed upon which we're exploring things, just to give you some insight, agentic AI is something that we are actively exploring, but it is not something that we have wholly rolled out as of yet. And the biggest thing here is that we are assisting RESC every step of the way to ensure that the data that it intakes is something that can be done with high efficiency, high accuracy, because accuracy is extremely important to our line of work, and we cannot allow anything to get out that could be construed as a mistake, a problem, or hallucination.
Thank you. Go ahead.
Yes. Hello. So CW4 Scotty Stock. I'm for Colonel Wilson and for the rest of the panel too. Sydney, you had spoken about return on investment, not just counting tokens, but how are you actually employing AI and getting something back? So what I would like to ask the panel is, how would you guys look at building with those KPIs that users could demonstrate to their leadership or to organizations to understand the value they're getting out of that token spend, not just saying, hey, we're spending tokens, we're adopting AI. What does all that actually mean? So if you guys could give your point of views on that.
I'll go first. I'll go first on that one. With the Pulse Check initiative, there is one very measurable outcome that we have already seen in our test cases, which is higher participation rates. You go from 60 to, you're battling, you send out emails, please get in and do the survey. Get in. I'm sure this exists in the civilian world as well. And you battle for 60, 70%, and you're barely scratching the itch of, is this statistically reliable data? Whereas because the way we've designed Pulse Check, it's not CAC enabled, it can do it on their phones, it's all still in the protected cloud, you're getting 80-90% participation rates. So measurably, that is a good thing. And then the other thing is the speed. When if you're participating in a survey and you put your feedback in and you don't hear from your boss for 4 months about the feedback you provided, there's a loss of faith there. Whereas if you hear from your boss in a couple of days on a comment that you made, that itself creates a very powerful thing that it's hard to measure, not as much as participation rates, but it shows an investment in the people and the right kind of culture that's going to lead to some measurable readiness gains, some intangible, but I think that's where we're going to see a lot of our progress.
I can go next. So we see this and we help our customers in really understanding both the input side and as well as the output side, right? So that if we think about that framework, see it, all the way through prove it, right? We need to make sure we're tracking the right piece of information to assign it to the right groups, to then ultimately understand what that and how we can drive that mission forward. So it's ultimately going to be organizational specific, but we really need to and organizations need to understand what it is that outcome that they're driving for, that they're driving towards, and really trying to put in some sense a value or dollar value to what that unit price is. So for in industry, or in public, in private industry, that could be the cost per unit, or for Nike that's shoes, for Uber that's drives, or whatever it is, right? So you need to understand what it is that the outcome that you're trying to drive towards, and then make sure that you have the telemetry and the measurement all along the way, and the attribution all along the way, to really understand the value or the cost throughout that process, to then make a determination of, am I getting value? Am I going down the right path? If I continue to do this, is it worth it?
Yeah, I think probably no surprise to you, we take a very deeply scientific approach to things and how we explore AI. So we have a very core group of folks that are known as our testers to explore options for artificial intelligence, whether that's a chatbot, a code assist type measure, working on agentic modeling and AI measures, or even trying to explore how we can use numerical weather prediction and artificial intelligence together. And so from there, as we feel more confident and comfortable with what we are seeing, we then explore a community of practice type model and start training the workforce on the capability that is out there for the AI tool, capability, methodology that we wish to deploy, all while working through risk management, privacy laws, and things of that nature. And then once that part is comfortable, then we deploy and roll it out to the entire workforce. And that's where we have determined the value. We have assessed that this is a capability that will add great value to what the workforce is doing within NOAA.
If I could throw one more on, I think I'll talk about, there's different types of measurements that you make, right? You have usability, which is maybe the participation the Colonel was talking about. There's speed of a process that you can measure, right? There is the expense of that process. One that is really hard to measure, though, is the quality of the outcomes of the process, right? How do we measure that without throwing humans in the loop to look at every piece of output that an agent is throwing at you, right? As that amount of work grows, can we scale with it? So one of the things that I think we have found very useful to explore is using the agents themselves as judges of quality, right? Models as a judge. And that's takes a little bit of getting used to, but I think that applied right, it's a triage step at the very least that can very much help you understand, is the quality suffering because my speed is increasing? Or is the quality improving because my participation is increasing, right? So I think that's important to think that is a hard type of metric to capture and measure, but with models as a judge, you can get there.
Agents assessing agents? Yes. I like it. Your question?
All right. Thank you. My name is Dan Greenfield. I'm with IBM. This question is for Stefan. You had mentioned that NOAA is using AI to move from minutes to seconds in storm reporting and even identifying wildfires before 911 calls. As those AI capabilities mature, what becomes the bigger challenge? Improving the models themselves or securely integrating those AI-driven alerts into the operational systems, workflows, and human approval processes that turn that into actionable insights?
That's an excellent question. I think as we continue to mature these capabilities, one of the things that, especially when it comes to wildfire detection, is we want to be able to mature and increase the capability that it brings, and then start exploring what could be the next step in order to help the communities prepare for what is coming. So one of the, we're working with wildland fire agencies as well as across multiple agencies to figure out, now that you have this additional time and a potential alerting capability, what can we explore here and what can we do to mature this process? Another step that we're taking right now is we are exploring artificial intelligence in the severe weather space very closely, looking at all of the data and information that is coming into us. So Warner Forecast System, it's called WASCAS if you want to look it up, is another artificial intelligence capability where we're using rapidly updating weather models with artificial intelligence hand in hand to see what we can do to identify environments that are more or less favorable for tornadoes and severe thunderstorms faster. We're also exploring capabilities to be able to allow AI to help forecasters in the warning process. Again, I emphasized earlier the human over-the-loop process. That is probably the biggest challenge that we face because, as this gentleman right next to me mentioned, you have to make sure when you validate something, it has to be done with a high degree of accuracy. We are in a business where inaccuracy is not something we can permit because we have a lot of people that depend on it, because millions of people sometimes depend upon what we issue and what we put out there. So those are some of the bigger challenges that we face. It's a very iterative process. It is an intensive process. And the other part is that we have a lot of data. When I asked the Chief Data Officer, Noah, how much data does NOAA have that's available for artificial intelligence, he indicated that that number was north of about 600 petabytes. That's a huge number, and we add gigabytes to terabytes of data every day because we have satellites that look at the landscape every 30 seconds. We have radar that returns a scan every 6 seconds. We get observational data minutes to seconds. We also receive data from aircraft, and you can imagine how much data that is for a human to be able to assess, and so that is the next landscape that we are exploring.
Yeah, I have a question for Colonel Prescott Wilson. First of all, thank you for your service from one colonel to a retired colonel. Secondly, I think we would all agree that the rapid advancement of AI is a conundrum for government adoption at the end of the day. There's always been a lag effect between technology and eventual government adoption because of policy and politics and acquisition, et cetera, et cetera. And what you've hit upon is a reserve unit with talent and expertise that then you can migrate into active duty forces and units. I'd like you to comment on what you see more big picture as a way to ingest that sort of AI expertise by really connecting in reserve forces in ways that we haven't before.
Fantastic question, sir. Looking forward to chatting with you later. I would tell you that I didn't know I had a problem. I've been participating in DEOX surveys, defense climate surveys for years, and I've been on the receiving end of them where I got a whole bunch of data saying you're above or below threshold on all these metrics, and then you get 70, 80 pages of comments. Some written well, some not written so well, but it was just 70, 80 pages of comments from the ranks. And then the sergeant major and I would just plow through it, read all of it, kind of assess what'd you see. Enormous consumption of time that I just took as what you do, because you just sort of have to do that, and you have to invest that time in order to get the most out of it. I didn't know there was an alternative until I had someone who had the deep expertise share with me what was possible. And so that is step one, is getting people out with the active duty units to do what forward deployed engineers do: observe and watch and say, did you know that there's an agent on your computer right now. You can create an agent who can do what you're doing much, much faster than you're doing it right now. Though it's not just old colonels like me who will go, that sounds really interesting. There are NCOs, there are sergeants who are doing things in 1990s styles that if they even knew what was available out there, they could accelerate and improve. Not just the speed, but also the quality, as Brian mentioned, of the outcomes. That is step one, is just get the information out there. Two then is the empowerment. I mean, PulseCheck it's a great story because once we had the epiphany of what could happen, we made the prototype, we started working through the bureaucracy. Turns out that you find the obstacles as you go. Surveys are controlled. There's a whole litany we've been trying to work through, but in order to get surveys in the hands of unit commanders to roll them out, there's a whole set of rules you have to follow and everything else. We've only discovered that as we've started breaking the brush. And so what I really hope through the partnering and through, let's have an experiment, let's get something rolled out, and let's find these obstacles so the next project can go a little bit faster, and it can be rolled out from idea to whiteboard to app on someone's computer to accelerated improved outcomes in a much shorter time span. That's what success is going to look like, hopefully in the near future.
Thank you for the questions. I actually have a few I'd like to ask before I let you guys go. Anyone can jump in on this, but I wanted to come back to something Sydney said about the parallels between AI adoption today and the early days of cloud adoption. What lessons from the cloud transition do you think organizations should apply now to avoid repeating some of the same challenges with AI?
Yeah, absolutely. So a lot of the same concerns apply. You went the big transition from cloud, from before cloud to cloud, was this idea that you would have infrastructure that you'd buy, and it was a capital expense, and you'd sort of make some investment, and you had a place to put it, and it was fixed. It was a known cost. And now what we've done with the cloud, and increasingly so with AI, is this is no longer a capital expense. This is an operational expense. So it's a different way of thinking about it. It's a different way of understanding it. Organizations need to plan differently for capital versus operational expenses. So just from the financial modeling perspective, right? There's a lot that you can carry over and a lot that you can learn. But a lot of organizations have been doing that already with cloud, with FinOps in particular. And so that muscle exists, and so it's sort of reactivating and retraining that muscle and thinking about it differently as the services change, as the level of detail from these new models and these new ways of procuring this software changes. So there's going to be it's certainly a new problem, but there's a lot that you can carry over from those skills that and those reps that you had in understanding that change.
We are right at the end of our time. Does anybody want to add anything quickly in the last 20 seconds? Otherwise, thank you for this lovely conversation. I'm going to turn it back over to Amy. Colonel Wilson, can you lead us off the stage?